Hi everybody, my name is Nick Arellano, and I wanted to record a video today to show something pretty cool that I've been testing over the last couple of days that I think would help a lot of people that are using MikroTik. So if you have been SNMP monitoring your MikroTik devices, you probably have noticed in the MIB that there is a lack of monitoring capabilities for routing protocols specifically, and maybe a handful of other things. Like if you want to monitor OSPF neighbor states or BGP session states, unfortunately, there's no way for you to really monitor that using SNMP. I know some people who have tried some workarounds, such as creating bridge interfaces for each peer and using a scheduler in MikroTik to monitor that internally and disable or enable the interface based on the neighbor state. That way, their network monitoring system that is tracking interfaces can at least see when that goes up and down. I know other cases, and I've done this in the past, where I have sent syslog messages to a syslog server to parse when a neighbor goes down as well, but not all platforms also have a message for when the neighbor comes back up fully. So in MikroTik, that's not super helpful. But with the addition of the REST API in RouterOS version 7, you basically have the power of the command line available to you over HTTP. And a network monitoring system such as NetXMS has the ability to pull data over HTTP endpoints. If you're not familiar with NetXMS, it's an open source management and monitoring solution that covers network topology discovery at layer 2 and layer 3 to build dynamic maps. It has a syslog server and parser built in. It has its own scripting language built in, which is very powerful for automating or monitoring systems. So if we look specifically at the documentation for NetXMS, every metric that you monitor in NetXMS is referred to as a DCI, or data collection item. And inside the documentation, you can see data collection from web services. So the REST API is a web service. And if we scroll down a little bit, you'll see that starting at version 3.8 of NetXMS, the agent service itself, it has the web service disabled. So you have to turn that on in the configuration file. But then you can create these web service definitions, and they are basically a URL path, as well as authentication, and just some options for retention and request timeouts that you can make HTTP calls to an endpoint. So you'll notice there's not a lot of other configuration options in here, and that is because these web services will reach out to make a API request, and it will take the JSON data back from the response, and then you can further parse it to get specific data out of the data structure that comes back. So you'll see there's a syntax here with a colon and some slashes to pull data inside the JSON object, and we'll go over this in some detail when we actually create these. Another important thing about NetXMS is it supports instance discovery. So if you have an SNMP table, for example, of interfaces, and you want to crawl through the interface and generate a data collection item for each interface and have each of those monitor FCS errors, you can have it dynamically generate all of those based on the ports that are available for that device. Well, you can use that same mechanism over the JSON list that comes back for any endpoints that return a list. You can have it dynamically generate the items. So if we take a look at the actual API in MikroTik, I have two examples here that we're going to set up in NetXMS. One of them is just the system identity. So if I go to /rest/system/identity and send the request, I'm going to get a JSON object back that has a key of name and a value of the device name. This is just a simple JSON object that is returned, and if I go to the BGP sessions and hit send, you'll see I get a list of JSON objects that have a whole bunch of data. Just as I did in the terminal, I can pass a prop list in the query parameters to filter this down to name and established, for example, and I can hit send, and you'll see I get a more condensed list of all three items. Because this is going to be monitoring and potentially polling every minute, it's a good idea to filter this down just to what you need so you're not wasting data and you're not using any extra resources on the device to generate the list. So now that we've seen this endpoint as a list and this endpoint as a single object, we can look at how we would create this in NetXMS. So in NetXMS, in order to create these endpoints, remember in the documentation, as I pointed out, you have to go to configuration, you have to go to web service definitions, and we're going to create the easy one first, which is just getting the device name. So each of these needs a name. So I'm going to call this MikroTik _system_identity. because you might have lots of these in the system, so it's probably a good idea to prefix it with maybe the vendor and what data is coming back. So I'm going to go back to the API client and just copy this URL as it is and paste it in the URL. And then I'm going to switch the authentication to basic auth and pass in some test credentials I created on the device. And I'm going to turn off the certificate validation because it is a self-signed certificate and we're just testing right now. An important thing to know about NetXMS, like I mentioned earlier, it has a scripting language built in, and it also has these global macro variables that are available to you. If I do %a, that is going to substitute this for the primary IP on the device that this service is being run on. So because I want to reuse this on multiple MikroTiks, I'm going to wildcard this out to be replaced by NetXMS when it runs. So we've got this endpoint here, and I'm going to hit OK. And so when it calls this request, it's going to get this exact object back from the router when it returns the response, just like we did in this API client. So in order to actually use it, we need to go into the object, right-click, and go to Data Collection Configuration. And then I'm going to click New Parameter by right-clicking in the empty space or clicking the plus sign above and going to New Parameter. And as I said earlier, NetXMS supports lots of methods for pulling data. In this case, we're going to use the web service instead of SNMP, for example. And if I click this button, it's going to prompt me to choose one of the definitions that I have set up. So I'm going to pick the MikroTik system identity one that we just created, hit OK. You'll notice that it created a colon at the end here. And if we go back to the documentation page, you'll see that it has this special syntax here to get the data that we want out of the object. Now, when talking with the NetXMS team in the Telegram support channel, they said that the parsing here uses the JQ syntax. There's a command line tool called JQ that lets you parse JSON objects. So we can use that same syntax here. So I have a little website called JQ Play that lets me put filters in here, put the JSON data in here, and see how the data is going to be manipulated with the filter that I place in there. So if I go back over here, since we want to monitor the device name in this example, I'm going to paste that in the JSON section. And we're going to see, basically in order to monitor this as a metric, I want to pull the value out of name here. I don't want to monitor this whole JSON string, because for some of these, you're going to want to do comparisons or set thresholds on what this value happens to be. So using this JQ syntax, if I want to grab a key from a specific object, I can use the dot notation and specify the key that I want the value from. So .name is going to return the string value for the name of the device. So I should be able to copy this as is, go back to NetXMS, and I should be able to paste it right here after the colon to tell NetXMS how it needs to pull the data out of the JSON object. So as soon as I hit OK, and actually I'm going to give this a better name, so I'll call it system-identity, hit OK. And because I added it straight to the device, you'll see it's a darker color compared to these ones, which are coming from a template. I should be able to go to the device now and see it reflected here. So you'll see this is the name of the device, which matches my terminal. And just to show that this is working, I can go to System, Identity, Set Name to Testing, hit Enter. Now, if I go back into NetXMS and I right-click this row, and I click Force DCI Poll and refresh, you'll see it's going to show the new name because it made a new API call to the router and populated that field for me. So I'm going to switch this back to the previous name. I'm going to right-click here, Force DCI Poll again, just to reiterate. It's pulling the current information. And I also get history every time it polls, so I can see when this changes over time. So that's pretty cool, but NetXMS already knows the name of the device, and this isn't super useful. So a better use case is monitoring things like the BGP sessions. So on the router, if I go back to routing BGP session, and I pass that prop list back in, so prop list, print, prop list, and then name and established, we get this value, these values back. And now something that's important is remember the JSON object is a list of objects. So it's going to behave differently when I try to parse it using JQ syntax So I'm going to open up the environment here and paste this whole list in here. And you'll see that .name errors out because it cannot index the array with string name because I'm working with a list. So in the JQ syntax, I can do the square braces to get all the items out of the list. I can also use an array index in here to grab maybe the first one. But what I need to do in this example, it's a little more complicated. So what I want to monitor in NetXMS is the established state of the peer. But I also want the name of the peer to be generated as part of the data collection item in NetXMS, so I know which peer is being monitored for each item. So in NetXMS, the first thing we need to do before we can look at that is actually create the definition. So I'm going to click the plus sign on the top right again, and I'm going to grab the whole URL, including the prop list, to make sure it's filtered down to just what I need. I'm going to swap out that IP for that %A again to have it swap out with the IP address of the host. And then I'm going to call this MikroTik BGP sessions. So remember, it's going to call this endpoint, and we're going to have that list that is available in JQ right now. So I'm going to pass the credentials in, turn off verification for the certificate, hit OK. Now, if I go back to the data collection items and I go to create a new one by right-clicking, going to new parameter, the difference with this is I need to use instance discovery. And with instance discovery in NetXMS, it needs something to iterate over. So for example, on SNMP, you're probably going to iterate over all of the items under a parent OID. But in this case, I need to tell NetXMS what I want to iterate over. And when you do the instance discovery, the value that is returned during the instance discovery becomes available as a variable called instance. And we'll see why that's important in a moment here. So in order to make this web request, of course, this needs to be set to web request, and I can select the one that we just created from BGP sessions. So the instance discovery page doesn't have a button to select these from, but we still need it inside this field, and that's in the documentation. So this right here is going to tell NetXMS what do I iterate over to know like what to generate for data collection items. And remember, whatever returns from this list as it creates the items, it's going to populate whatever value that we search for as a variable called instance. So what I want to do for monitoring is get the instance name from the peer here. And then on the general tab, the metric that I want to monitor is actually the established state. So in order to do this in instance discovery, I need to give it the correct syntax to get a list of just the names of each peer. So it'll loop through each one and have the name available. And in order to do that, we can go into JQ to show an example. So if I select this whole list, now that I have the list selected using this syntax, now I can actually chain at .name, and it will pluck the name key or the values from the name key out of all the objects. So now I have a list of all the names that I want NetXMS to iterate through. So I can literally copy this as is, go back to NetXMS, and then I can paste it in this field. So you're telling NetXMS to select the name key out of each of the items and give me that list of strings and loop over it, which will now give me access to a variable called instance that I can use on the general tab. So maybe on the name that I want, I might call this BGP sessions dash, and then I can say instance here, which will be populated with the string of the peer name. And then I might want to put established here because that's what we're monitoring. So now the tricky bit here is I don't need this instance here because I want to monitor like the established value. And if I switch back to JQ and let's say I do established, well, this isn't that useful for me in this context because I have 3 values of true and I can't tell like which one this belongs to. So with this list, we can pipe it through a select, and this select is basically it will run against each item in the list to filter the list down. So what I want is an item with a name that is equal to specifically one of these, because we'll have this available as the variable instance. So if I use this, you'll see already it filtered the list down to that one item. And then I want the established value off of this, which is true. And you'll see if I go up here and I swap this to 1, it evaluates to true. If I swap this to 2, it evaluates to true. And because in NetXMS we have that instance variable, this can be swapped out on the fly for each iteration to pull that established value off. So I can take this as is and switch over to NetXMS, and I can literally paste it right here. But remember, this is hard-coded. I don't want that. I want to swap this out with the instance variable. So now it's going to, for each one it generates using this instance discovery by name, it's going to be able to pass the name into this filter here to filter it down to that individual item and grab the established field off of that item. So to see if this even works, I'm going to persist it. And because this is using instance discovery by default, it's not just going to pop in here like this one did. There is a background job that runs at a certain time interval to do this automatically, but I can force it by right-clicking the device, going to poll and instance discovery to force it to go through these items. So you'll see that this is the syntax we were using, and you can see it's creating a new DCO, data collection object, for each of those instances. And if I go back to the objects here and look at the values, you'll see I've got 3 dynamic peers here. And it's populated with the instance name because that's what we told it to pluck in the instance discovery, and it's pulling the established field. And just to show that this is actually working correctly, I can go into the router and do system SSH into, we'll do router 1, so 10.0.99.61 with user also testing. And I'll go into routing BGP connection, and you'll see the connection is listed in here, and if I disable it, I should see in here that session is gone. There's only 2 sessions now. Or no, all 3 sessions show, but you'll see that that flag is missing. And if I go into that device, which is VPN1, and I force a DCI pull and refresh, I got an error. Now this might be confusing at first, but if we open up the API endpoint for the MikroTik and I make another request, you'll notice that established is not an actual field that you can type into. It's a flag in the peer. So if that flag is not present, it doesn't even show up in the JSON body. But we can account for that if we switch over to the JQ environment. So if I wrap this whole thing in parentheses, it's basically just selecting the same value that we had, but now I can do a / / and pass a default value. So you'll see this value is true. So it's evaluating to true. And if I switch it to false, it evaluates to false, but that's just because it's plucking it under established. But if I completely delete this and it's null, and you'll see if I remove this end bit, it does actually evaluate to null. And if I put this back in, you'll see it will transform it into false. And you'll see if I go through each of the VPN devices, it's going to evaluate the correct item. And 2, and 3. So I can modify in NetXMS to do the same exact thing so that if it is missing, it's just going to return false for me. So I'm going to go back to NetXMS. I'm going to open that data collection item, and I'm going to wrap this whole statement here in parentheses and do a / / and false and hit OK. And once I do this and I go back to the device and I repoll it and hit refresh, you'll see now it's evaluating to false instead of erroring out. And now I should be able to go into the other device. So system SSH address 10.0.99.61 and user is testing. And I go back into routing BGP connection and I enable 0 and I force a DCI pull here and hit refresh. It's now true. And another thing that's nice about NetXMS with these data collection items is if I go into the data collection item settings by double clicking it, and I go into the thresholds tab, I can actually add a threshold that says, if the last pulled value for one sample, I could make this 3 samples. By default, the server is set to pull minutely, so this would be 3 minutes. But for now, I'll just set it to 1. And if I say the value is not equal to true, because we are expecting the session to be up, and I hit OK. Well, if I go back to the device here and I select these 3 and force pull them and refresh, everything should be green. And you'll see the device on the sidebar is green. But if I go back in here and I disable 0 and I pull these again and refresh, you'll see it is now in a blue state, meaning that there's a threshold violation because the last value is not true, it's false. So now it is throwing an alarm in the system. So if I go into the alarm browser, you'll see that there is a threshold for this device that is thrown, which can then trigger a notification if you have that set up in NetXMS as well. So that's pretty cool. So this is only applied to one device right now, but NetXMS also supports templates. And I do have a template set up in here under MikroTik for BGP, because not all of the MikroTiks on the network might be running BGP, and they might not even have the API enabled. So you can separate these into a special template, and I call this one BGP. If I go to Properties, and I go to Automatic Apply Rules, I'm basically checking to see if this is a MikroTik, and I'm checking to see if the name happens to be REO-lab-BGP. You could make this just BGP, but I have other devices in this NetXMS server that I don't want to populate in there. So now I have this template that is specifically looking for devices with this in the name. And if I right-click this and go to Poll and Automatic Bind, nothing shows up. But I can go into the data collection items, or this one, for example, and I can move this to, or convert it to a template item. So I can go into my templates and go into that one that I just showed for BGP. And now it's gone. And if I go to the object details and go to last values, you'll see that they're currently present, but if I do a poll on instance discovery, it's actually probably still stuck on the item. So let me take this and delete it and pull automatic bind so that it detaches. So if I look at the object, they should be gone. It automatically bound it when I converted it to a template item, but now you'll see that they're missing and there's nothing added into the network here, or the template here for BGP. And if I pull again, nothing's being bound to it, and it's not monitoring BGP on this device. But let's say I go into this device and maybe the organization has decided that, if we follow that naming convention, we're going to assume that it does have BGP running on it and the API is open. So I'm going to do system identity set name to REO lab BGP, maybe 01, for example. And if I right-click this device and I pull the configuration, it's going to rename the device based on what's in the device now, and you'll see it automatically bound to BGP. And then if I now do an instance discovery, or let it naturally do it over the course of whatever it's configured on your server, you should see that it will populate that. Let's see, let's run this again. Instance discovery. And you'll see they're all here again. If I do routing BGP session print, you'll see it is now monitoring these. And what's cool about this is any item in the system that has BGP in the name is now going to be applied to this template, and it's going to start monitoring it this way dynamically based on what peers are set up in the device.